Once you have your data, then you're ready to graph. Here I'm using graph paper, and I've already laid out my paper having an area for a graph on top, and then we're going to have the analysis and the conclusion on the bottom. I'd like for you to try to do this on one piece of paper if you can. When you go to graph, you need to make some decisions to begin with. First of all, you need to know which variable is going to go on your y-axis and which variable is going to go on your x-axis. For this particular experiment, we are going to be putting volume on the x-axis and mass on the y-axis. And the reason we're doing that is because we're trying to find the density of the gravel. And in order to find the density of the gravel, I'm just going to go ahead and write this down here. Density is equal to the mass over the volume. And we can determine this density graphically if we measure the slope of the line of best fit, and the slope is the rise over the run. So in order for this to work out, we need to have volume on the x-axis. We put the variable name and we put the units in parentheses. Now we're going to have mass on the y-axis. So we have mass in grams. The next thing you need to do is to decide how your tick marks are going to be numbered. And for that, you take a look at your data. So for the volume, the range of data is going between 2 and 8, or we could say between 2 and 10 milliliters. So the range I would write as going from 0 to 10, with 5 being in between. The range for our mass is going from 3 to 25, or if we extended that, take it all the way down to 0, and then let's take it all the way up to, say, 26. So here I would have 10, 26. So this would be 20, and this would be, each smaller tick mark would be 2. So 20, 2, 4, 6. The important thing here is that your tick marks are equally spaced. Each tick mark has the same value. We say that the axis is linear, so that each tick mark has the same value. With the axes all set up, we are ready to plot our data points. So now you can see why we call this a scatter plot, because we have a scattering of our data. The next step is to draw a line of best fit, and you need to use a straight edge, and I like to use a clear one so I can see what's going on both sides of the straight edge. A common mistake that students will make is on a scatter plot is to connect the dots, and that's not what a scatter plot was. If this was a trend line, if this was a line graph where we were looking at a trend for time, then we might connect the dots. But in this case, this is a scatter plot, and we're going to draw a line of best fit. So when I draw my line of best fit, by definition, the line comes as close as possible to as many points as possible, and what that means is that you're going to have as many data points above the line as you do below the line. So I see I have 2 above the edge of the ruler, and I have 2 below. So I am going to extend this line all the way to 0. And it makes sense that it makes sense that our line of best fit goes through 0 because, of course, when the size of the piece of gravel goes to nothing, then it will have no mass either. So it makes sense that we can anchor our line. Sometimes I tell students to just take your pen, stick it right at 0, and then you can play with the angle until you get it just right. And so just a couple of things I want to clean up. I think I want to make a line here for my x-axis and a line here for my y-axis. I think I have everything I need. I got a title, I have my x-axis, my y-axis labeled correctly, my line of best fit, and my scatter. So now in the next video we'll move on to measuring the slope and doing the analysis.